Hey guys, welcome to another lesson on the Pythagorean theorem. Hopefully you've been kind of catching on to what this is all about. You know, right? It's right triangles. We have a right triangle, meaning a 90-degree right angle. If we have two of the three sides, we can always find the last side length, the missing side length. So we have A, B, C. The two legs are A and B touching a right angle, and the C is our hypotenuse. So A squared plus b squared, the two legs squared, always equal the hypotenuse squared. So the area that forms off of A plus the area that forms off of B always equals the area of the square that forms off of C. So today we're going to be looking at how can I use this Pythagorean theorem to find the distance between 2 points in a graph. So I can use the Pythagorean theorem the distance between 2 points in a graph. So whenever we have 2 points in a graph, we can always find that distance. A lot of times you look at this and you, how in the world will we find the distance? Okay, it's a diagonal, and a lot of times you try and count them, but you can't count them because they're not full boxes. They're not full. So when it's on a diagonal, you don't really know the distance, the true distance. So a lot of people look at this and we don't know how to do it. They don't know how to find this distance, and they don't connect that we can form a right triangle. We can use our Pythagorean theorem to find this distance, and that's the key. And that's the connection we need to make today. And then it becomes rather simple, right? This is something we can do, but we have to be able to use the Pythagorean theorem to make that connection and to be able to do this. So our first goal is how can we make this into a right triangle? Because right, the Pythagorean theorem is right triangles. So how can we make this into a right triangle? So we're going to make this into our right triangle. And there's our right angle right there. So now we have a right triangle. And a right triangle, right? So for the Pythagorean theorem, we need 2 of the 3 sides. So a squared plus b squared equals c squared. So we need to find out 2 of the 3 sides so we can find our missing side. So which of these sides do we know? What do we know? Well, we know this distance, this leg. How do we know that leg? Well, we can count if we want to, or we could find out that we're 4 above here, y of 4, and we're at y of -2 here. I guess this is going by each box is a half on this coordinate plane. That's not always true, so just bear with me on that. But this is going by 2's. 1, 2, 3, so each of these boxes is worth a half. So you gotta be careful with that. You gotta make sure you understand that. But so if we're at 4 here, if we're at -2 here, so each of these boxes is worth a half. So that's 1, 2, 3, 4, right? 5, 6. So this distance is 6 units. So this leg is 6 units. This distance here, if they're each, if we're going by 2, so we're at 3. And this is halfway. This looks like it's 1.5, right? It's halfway. So this is like 1. Kind of mess that up here. So this is like 1, 2, 3, 4.5. So this is 4.5. So our legs are 6 by 4.5, and we're trying to find our hypotenuse, our C. So we have 6 squared plus 4.5 squared equals c squared. 6 squared, I know that one. I know that's 36. 4.5 squared, I don't know that. So I'm going to get out my handy dandy calculator and do 4.5 squared, and that's 20.25 equals c squared. I add those together, so 36, 20.25 plus 36, 56.25 equals c squared. And this is review, guys. This is using our Pythagorean theorem. Square root both sides. So this would be radical form, but then it says round your answer to the nearest tenth. So I'm going to round that. I'm going to go ahead and do the square root of 56.25. 56.25 square root that is 7.5. So we have 7.5 is c. So the distance between this point and this point is 7.5 units. If you're confused, let me know. If you're not confused, I'm sorry, I have no idea why this just came up. You guys don't need the list of sources students. Alright, so that is our distance between those. Alright, moving on. So on this next one, we are going to be looking at same problem, but now I did not give you the coordinates. So we have to figure out, well, what are the coordinates? We have to go back to some of our previous stuff we've worked on in the past, and how do we find coordinates in a coordinate plane, which will help us at this. So on this one, what's this coordinate right here? Remember, we always do coordinates x, y. Coordinates are always x, y. So this is our x, and this is our y. So this would be the coordinate 3, 4. And this would be the coordinate -2, -2. Left 2, down 2. -2, -2. And this one's nice. It's just going by 1 unit per box. So then how are we going to find the distance of this green line? The distance from down here to up here? Well, we're going to need to form a triangle. Hopefully you said triangle. Not only any triangle, a right triangle. So we're going to need to form a right triangle. So what is the distance of this leg? So we're going from 4 to -2. So 4 to -2, that's 6. That's a difference of 6. Up from -2 to +4, 6 units. 1, 2, 3, 4, 5, 6 units. We're going here from -2 to 3. So that's 5 units. 1, 2, 3, 4, 5. So our two legs are 6 and 5, and we're missing our hypotenuse. So we have 6 squared plus 5 squared equals c squared. Well, this one, I can do those. I know 6 squared is 36. I know 5 squared is 25. I know 36 plus 25 is 36, 46, 56. So 61 equals c squared. 36 plus 25. 36 plus 25 equals 61. I square root that. Nearest tenth would be 7 8/10. So square root it, cancel, 7 8/10 equals c. So this distance of this green line is 7 8/10 units. So we're finding distances. Remember, our goal here today is, can I find a distance? Can I find a distance between 2 points in a graph or a coordinate plane? Alright, moving on to one where we actually have to plot the points. We have to use coordinates and plot the points. So, can you plot points? That is the question on this next one is, can you plot points? Can you determine where these coordinates go? So we have -3, 6. So remember x, y. This is our x and this is our y. So -3, 6. That's our first one. 5, 6 is the other one. So +5, +6. And our last one is 5, -2. 5, -2. So we have our triangle. Now we need to find the hypotenuse of this triangle. So in order to find this hypotenuse, we're going to use our Pythagorean theorem. Very good. So same thing. Alright, so what is this distance of this leg right here? This leg. So we are -3 to +5. That's 8 units, right? 1, 2, 3, 4, 5, 6, 7, 8 units. So that's 8. We're at -2 to +6. That's 8. 1, 2, 3, 4, 5, 6, 7, 8 units. So we have an 8 squared plus 8 squared equals c squared triangle. 64 plus 64 equals c squared. So 128 equals c squared. Square root. 4 plus 64 equals, we square root that, 11.3. So 11.3 is the distance of our hypotenuse of that triangle we just graphed. Alright, so this last one, I may run out of time, guys, so you might have to finish this one on your own. So just be aware of that. You have to plot the triangle and then find the diagonal distance. Sorry, not triangle, rectangle. I think I said rectangle. So on the same coordinate plane, you're going to have to plot this rectangle. So -5, 4, xy. So we go -5, +4. You go 3, 4. 3, 4. You go 3, -2. And you go -5, -2. So we have our rectangle. Now, your job, what you need to do, there will be a question on this. What you need to do is you need to use your Pythagorean theorem to find this diagonal. So you can either use the top triangle or the bottom triangle to find it. So what is this leg? Well, we went from 5 to -5 to 3, so 8 again. 1, 2, 3, 4, 5, 6, 7, 8 units. 1, 2, 3, 4, 5, 6, right? 2 to 4. So we have an 8 squared plus 6 squared equals c squared, where c represents our diagonal length. So 64 plus 36 equals c squared. You need to finish this problem and find the distance of c. There's lots of practice problems on here to practice with the answers. There's also an assignment that goes along with this lesson. I hope you learned something today. I hope that you can now find the distance of 2 points on a graph using the Pythagorean theorem. Hope you had a great day, guys. See you soon. Signing off, Mr. Urschel.